Ladies and gentlemen, welcome. We are going to do a post lab for projectile motion. Projectile is usually an object that is flying through the air. We are going to ignore air resistance in this. And normally for a projectile, if you were to draw a force diagram for it, you would just have Fg acting on it, being that there is no other forces acting on it as it flies through the air. So, in this situation, whenever you have a projectile, one of the things that we talked about in our pre-lab is the idea that you need a 0, 0 mark. Remember placing your position axes, and remember now that we have two of them, we have a horizontal position axis known as X and a vertical position axis known as Y. So, our graphs, if we were looking at this situation, should be the following. And I would copy this down because you never know when a graph could look like something different and the different changes. So, a couple of things to notice about our graphs. If we looked at the horizontal position versus time, you'll notice that it has a y-intercept. That y-intercept would be known as where it started on the x-axis. So that would be that position right there, saying that that is exactly where that object is at. And its final position would be somewhere down here, xf, which would be represented on this graph right there, xf. Looking at our y-axis, you'll notice that the object started here, which would be known as y naught. Again, that is our initial vertical position. And our final vertical position, you will notice that the ball gets down here, and you'll notice what final vertical position is it at? That's YF, which would be equal to 0 in this case, because it hits the ground if we were to say the ground is 0. Other aspects to these graphs that are very important to see. First off, you'll notice that the slope of this graph is equal to 0, which means the acceleration in the x direction is equal to 0. Or what you can see is in the x versus t graph, the slope is constant. And so what we can say is that we have a constant velocity. We would call that just Vx. So that, ladies and gentlemen, is a very important idea to walk away with, understanding that in the x direction we have constant velocity, aka ax is equal to 0. In the y direction, however, you notice first off that this is a curved line, and number two, the slope for this graph was actually equal to negative 9.8. And we realized something, that negative 9.8 is referring to free fall. The other thing to note is there are certain points on this graph, like right there. That is when Vy is equal to 0. What does that mean? That means when our velocity in the y direction is equal to 0, or when it gets to its max height in this certain situation. So you can kind of see that by looking at the tangent line, because you'll notice the slope of the tangent is equal to 0 at that point, being that that is the highest point that it ever gets to. So you could start to see some correlations between the graph, very similar going back to Unit 3. So if you do not remember that, I would say go check out those Unit 3 videos. They will be helpful. Other things to note. If we were looking at equations to use for constant velocity, the one equation that I would focus in on is that this delta x is equal to 1/2 at squared plus v naught t. Remember that a is 0, so when you plug that in, the equation that you get is basically our constant velocity equation, x is equal to vt plus x naught, or what you can rewrite it as what I've done over here, it's delta x is equal to vt. And you'll notice that I have one sitting right here, it's v naught x or vx. Just remember it's a constant velocity, so whether you're talking about the initial velocity or the final velocity, those are technically the same anyway, so you could use either one of those. On our constant acceleration side, you'll notice that all four equations, basically everything from Unit 3 works. You'll notice that I change these equations around just a little bit. Instead of using an x in certain positions or in certain places, you'll see a y that is referring to the vertical position versus the horizontal. You'll also note that I denoted a few different changes. Things like ay refers to the acceleration in the y direction versus just the acceleration in general. V naught y refers to the initial velocity in the y direction. Remember, everything that we talk about has both an x and a y velocities now. So we need to start thinking about that when we go through here in order to understand it. Notice that t is the one thing that does not have any direction associated with it. So we can do that. Or we can know that time is not a vector. It is not split up into directions. The last thing that I want to make sure you guys get in your notebooks other than this right here is understanding the key idea. We talked about this in class. You're going to see it used in the example problem. The x and y are independent of each other. So the directions stand alone. Whatever happens in the y direction will not change what happens in the x direction. Whatever happens in the x direction will not change what happens in the y direction. So this is a very similar situation where if I were to just drop a ball from a certain height, so this ball is just going to speed up going to the ground, or if I were to shoot that ball at a velocity of 1,000 meters per second, I can always ask the question of which ball will hit the ground first. Well, if I were to actually draw a motion map for this ball were to continue to move to the right. However, it is still going to fall in the y direction exactly the same as if it were to just be dropped. We'll take a look at a couple of motion maps in order to see this. We have a few little fun devices that you can play with in order to see that, yes, a ball shot versus a ball being dropped will act the same way in the y direction, being that no matter what you're doing in the x direction, whether you're shooting it or not, whether it has a velocity or not, it's not going to make a difference. So that's a key idea. We will make a big focus on that in these next couple of days. Cool. So watch the example video. I think the example video will highlight a lot of these main points. It'll give you a nice little structure that you can follow so you can complete the worksheet tomorrow. Thanks for listening. We'll talk about it next couple of days.